Hi, I'm Dr. Fox, and let's talk about the peritoneum. In this video, we'll discuss the peritoneum, its various layers, and what it means to be an organ that's either intraperitoneal or retroperitoneal. We'll talk about the peritoneal cavity. We'll discuss peritoneal specializations, such as mesentery and ommenta, and we'll detail some of the locations, connections, and specializations of the greater and lesser ommenta. But first, let's start with what is the peritoneum. The peritoneum is a serous membrane that lines the abdominal pelvic cavity. And as you may recall, every serous membrane has two distinct components to it. There is the parietal component of a serous membrane that lines the wall of the cavity in which the serous membrane lives. And there is a visceral layer or component of that serous membrane that is going to cover any of the organs or viscera within that space. So we refer to these specific components as the parietal peritoneum and the visceral peritoneum. So the parietal peritoneum is what I'm outlining now, and that's going to cover the body wall. And then the visceral peritoneum kind of pooches out, and it's going to surround organs and cover them, such that the most superficial layer of any organ, its serosa, is visceral peritoneum. This is also going to establish two types of organs. Those which are retro, so behind peritoneal, organs that exist behind the peritoneum, and those that are intraperitoneal, those that seem to be suspended within the peritoneal cavity. And that peritoneal cavity is just the space between the parietal and visceral peritoneum. And it's in this space that we have a little bit of peritoneal fluid, usually 3 to 6 tablespoons worth of material. So it's not chock full of fluid, just enough fluid to keep everything moist and well lubricated so that there's no friction amidst your viscera. So here is an illustration of some of the contents of the abdominal pelvic cavity, so within the peritoneal cavity. And we have an abdominal part of the esophagus there. We have a liver here. We have a stomach here, a proximal part of the duodenum. All of those are intraperitoneal organs. And so this space all about here, this is the peritoneal cavity or sac. And we can divide that into two separate spaces. A greater sac, which really is most of the peritoneal cavity, and a lesser sac. That lesser sac is the space that is behind the stomach and this hepatogastric ligament. If we go through here, that's through the epiploic foramen or the foramen of Winslow. We can move between greater and lesser sacs. So mesentery is going to be a double layer of visceral peritoneum that is going to anchor an intraperitoneal organ to the body wall. It's within mesentery that any of the neurovasculature, so the nervous plexuses or the vessels that supply blood to or drain blood from the digestive organs, are going to be transmitted. So all of that neurovasculature, and let's not forget the lymphatics, is contained between those two layers of visceral peritoneum as it traverses the body wall out to that organ. Now, mesenteries are oftentimes named based on their location. So for instance, there is a transverse mesocolon. The transverse mesocolon is the part of the mesentery that is anchoring the transverse colon, which is there, to the posterior body wall. There's also a mesoappendix. That's the part of the mesentery that is anchoring the vermiform appendix. And sometimes you'll hear people referring to something called the mesentery. The mesentery is the mesentery that is associated with the jejunum and ileum, so the distal 2/3 of the small intestine, which is going to anchor that to the posterior body wall. And here we can see branches from the superior mesenteric artery and tributaries of the vein that are being conducted through this mesentery on the way out to the small intestine. We also have ommenta. Ommenta are folds or layers of peritoneum that are associated specifically with the stomach and, to a lesser extent, the proximal duodenum, as we'll see. Now, the stomach as an organ has a lesser curvature, which I'm outlining here, and a greater curvature, which I'm outlining here. So there's the lesser curvature, there's the greater curvature. You'll notice that the greater curvature is much larger than the lesser curvature. Well, each of these curvatures are associated with their own ommenta. Between the lesser curvature of the stomach and the proximal duodenum and the liver and gallbladder is the lesser omentum. Whereas from the stomach all the way down and back up to the transverse colon, as well as to the spleen, as well as to the diaphragm, is the greater omentum. So, lesser and greater curvatures, lesser and greater ommenta. Now, each of these ommenta we can subdivide into various ligaments. So with the lesser omentum, there are two major ligaments. The largest is that of the hepatogastric ligament. Now, let's take a moment to think about that name. Hepato means liver, gastric means stomach. So the hepatogastric ligament is going to connect the lesser curvature of the stomach to the liver. There is also, right lateral to that, the hepatoduodenal ligament. So hepato, liver, duodenal, duodenum, or duodenum, which is the proximal part of the small intestine. The hepatoduodenal ligament is going to connect the liver to the duodenum. And we'll see that this hepatoduodenal ligament is going to conduct important elements of neurovasculature to and from the liver. So we have, going to the liver, two sources of blood, the hepatic artery proper and its branches, as well as the hepatic portal vein and some of its tributaries that are conducting blood to the liver, both from the celiac trunk that comes from the abdominal aorta and all of the lining of the GI tract through the hepatic portal system up to the liver as well. So we're sending both arterial and venous blood to the liver. And coming down from the liver and gallbladder, we have the bile duct and its tributaries on its way down to the second part of the duodenum. All complements of that lesser omentum. So two major ligaments there, hepatogastric, hepatoduodenal, and the smart money is knowing what those root words mean. Next up, the greater omentum. So greater omentum is associated with the greater curvature of the stomach. There are three major ligaments of the greater omentum, but most people know about the gastrocolic ligament, which is the lion's share of this. Gastrocolic goes from the greater curvature down and then back up to the transverse colon. That is quite a large structure that is imbued with quite a bit of visceral adipose tissue or visceral fat. It's 4 layers because it's a double layer that doubles over on itself. So we have 4 layers of visceral peritoneum there. And we oftentimes will refer to this as the omental apron because it hangs down anterior to the transverse colon and much of the abdominal pelvic contents. And so to see anything deep to that, you'll have to peel back the gastrocolic ligament. We also have two other smaller ligaments, the gastrophrenic ligament, which anchors the greater curvature of the stomach to the diaphragm. So phrenic references the diaphragm, and gastrosplenic ligament, which connects the greater curvature of the stomach to the spleen. So we've discussed the peritoneum, its various layers, and what it means to be intraperitoneal versus retroperitoneal. We've discussed the peritoneal cavity and its contents, its various specializations, in particular mesenteries, ommenta, and we've gone into some of the ligamentous details of the greater and lesser ommenta. Thank you so much for your time.